Okay, today we're going to talk about the law of sines and area. So what are you going to learn today? You're going to learn how to find the area of a triangle using sine, and then we're going to find out how to find the angle measures and the side lengths of non-right triangles. Okay, just a quick little refresher on how we name sides and angles. So angles, obviously, these are angles A, B, and C. The sides are named after, we can name them with a small letter according to the angle opposite. So that's side A. The side opposite the 51-degree angle is side C. And then the side opposite this is side B. All right. Now, when we go to look at the area of this triangle here, we have a formula that's going to make it a lot easier to do. And we can use it if we know sides and angles. So I'm just going to refresh. That's A, this is side C, and then this is side B. So the formula that uses trig is 1/2 the sides, two sides, A times B, and times their sine of their included angle. So actually in this case, so it would be if we know this angle here, so side A, B, and then the sine of C, which is this angle here, our included angle. So in the case of this example, it's going to be 1/2, and we know 10 times 5 times the sine of 31. And when we figure that out, it gives us approximately 12 and 88/100ths. And you can just put it into your calculator just like it is. So let's look at another example. Okay. Now we're going to have 51 as our included angle, so it's going to be, our area is going to be 1/2 times 8 times 6 times the sine of 51. Okay. And plugging that into the calculator is going to give us approximately 18 and 65/100ths. Now up until this point in this chapter, we've been able to find angles and sides based on right triangle trig. The sine and all of that only works with right triangles. However, we have another formulas, law of sines and law of cosines, that will let us find those with any kind of triangle. So today we're going to look at the law of sines. So the law of sines can be used to solve non-right triangles if I know an angle, a side, and an angle on the side, or a side angle. Okay, so if we know any of those three things, then we can find the other side. Now, up here in parentheses, it says, although this may be used for more than one solution, we call this the ambiguous case, and we don't do that in geometry. So you'll learn about that in Algebra 2 trig. All right, so basically what the formula is the sine of A over A is equal to the sine of angle B over B, which if the extended proportion is equal to the sine of C over side C. So what does that look like? If I want to find the remaining sides and the angles of this triangle, I can do that. So what I need to do is I need to find the measure of angle C, which we've been doing all year. You add up your two angles that you know. 30 plus 50 is 80, and subtract from 180 gives us 100 degrees. So this angle is 100. Okay. And then we're going to use the law of sines to find the missing side. So what I know is I've got side C here, and I've got angle C. So that's what we're going to use. So we're going to say the sine of 100 over 44. And if we go with B, let's find side B. That would be the sine of 50 over b. So this is a proportion, so we're just going to cross multiply. So b times the sine of 100 equals 44 times the sine of 50. Got to divide both sides by the sine of 100, so I get b equal to 44 times the sine of 50 over the sine of 100, and I can plug that into my calculator. After these examples, there's a slide there that will definitely show you how to plug them into the calculators and get things right. But plugging into the calculator, I'm going to get side B to be approximately 34 and 236 thousandths if we round to the nearest thousandth. There are 3 decimal places. Then to find side A, I'm going to do the same thing. Sine of 100 over 44 equals sine of 30 this time, because angle A is 30, over side A. And again, we're going to cross multiply, so we get A times the sine of 100 equals 44 times the sine of 30. And if I divide both sides by the sine of 100, that is going to give me approximately 22 and 340 thousandths. Okay. Now in this example, I've got 2 sides, but I don't have 2 angles. So I've got to find the angles first before I can find the other sides. So I'm going to go with finding angle A first because I've got side A. Okay. So to do that, I'm going to do sine of A over 19. That's its opposite side. And I know B is 35, so sine of 35 over its opposite side, which is 11. So now when I cross multiply, I'm going to get 11 sine A equals sine 35 times 19. And then I'm going to divide, so I get sine A equals 19 sine 35 over 11. Now we're looking for an angle, so remember we've got to use inverse sine. And you're going to have to put that in piecewise, so find what 19 sine 35 is, divide it by 11, and then take the sine of that. And in the next slide, I'll show you how we can do that without doing any rounding to the very end. And we're going to get angle A to be approximately 82.189. Okay. So the measure of angle A is about 82.189. And then we can add that to 35 and subtract from 180 to get the measure of angle C, which is 62.811. So now I've got my 2 angles. And now I've got to find side C. So now I'm going to use the law of sines again. So I'm going to do sine of 62.811 over C equals, I like to use the ones that were given, sine of 35 over 11. So if I cross multiply, I get 11 sine 62.811 equals C times the sine of 35. Okay, and then if I divide by sine of 35, C is going to be equal to the sine of 35, or I'm sorry, bad Miss Craig. It's going to be equal to 11 sine 62.811 divided by sine of 35. And again, I've got to use that inverse sine. And when I do, that's going to give me approximately 17.059. So now let's take a look at, okay, let's go over the calculator steps just to make sure that you have them down for solving these problems. I've written out the two different kinds of problems that we're going to have. So I'm just going to type in for the first one in black, 44 sine 50, and I'm going to press enter. So I've done the top, and now I'm just going to press the divided because that will put our last answer in there by sine 100. This is how I want you to do it. I don't want you rounding to the very end, and when we use the last answer, then it doesn't round until the very end. It takes the very last answer in. All right. I very rarely clear my calculator. I'm going to clear it now, though, to show you his other problem. Now for this, we're going to take it step by step. We're going to do 19 sine of 35. We're going to figure that out, enter. We're going to then divide by 11, and that's going to give us 0.999. Now we're going to do inverse sine of that. So we're going to do shift sine, which will give us the inverse. Then I'm going to do shift again, and down here above the negative sign where it says ANS, we put our last answer in. So we can put that anywhere in the problem and it will give us the very last answer that we've used. So it's going to give us the sign of that 0.99072222, whatever, so it's not rounded. So I'm going to press enter, and it gives me the 82.189. Okay, this is how it works on a TI as well. And so what did I learn? So today I learned to find the area of the triangle is 1/2 my 2 sides times the sine of its included angle, and I learned the law of sines. Have a math-tastic day.
Bye. Bye. Bye.